All right, everyone, it is 40 past the hour and we are live, so let's get started. Thank you everyone for joining us today at MLOps Machine Learning in Production, Bay Area. I hope you enjoyed today's sessions as much as I have so far. Just a quick reminder before I introduce our next speaker to check out our sponsored booth, which you can navigate to at the booth icon on your left for a chance to win some great prizes, including Amazon gift cards and a custom pair of Nikes. Now, without further ado, it is my pleasure to introduce our next speaker, Ville Tuulos. Ville has been developing infrastructure for machine learning for more than 2 decades. He has worked as a ML researcher in academia and as an infrastructure leader at a number of companies, including Netflix, where he led the ML infrastructure team that created Metaflow, a popular open source framework for data science infrastructure. Ville is a co-founder and CEO of Outerbounds, a company that continues the Metaflow journey. He is also the author of a new book, Effective Data Science Infrastructure, which is published by Manning. And he will be giving us a talk about human-centric MLOps and why productivity matters the most. Please give a warm welcome to Ville Tuulos in chat.
Thanks, Peter. Well, I mean, really great to be here today. Of course, like virtual events are always strange, so I can't see you. Yeah, like Peter mentioned in the beginning, I used to work at Netflix before, like where we started developing Metaflow. These days, I'm the CEO and co-founder at the company called Outerbounds, where we continue that Metaflow journey. Well, this presentation actually isn't so much about Metaflow. I wanted to talk about something that's more broad to our industry, to MLOps. And I know that there are probably 2 kinds of people in the audience, maybe practicing data scientists who want to deploy ML to production. And then on the other hand, people who build MLOps tools and maybe work at different MLOps companies. And I hope that both of you will get something out of this presentation. If you are a practicing data scientist, I hope to be able to convince you that you can expect more from your MLOps tooling. And then if you happen to be MLOps builder, I hope to convince you that it is really the productivity that matters the most. Maybe you already agree. And in that case, I guess you can just nod along. So I wanted to start the presentation by like showing you this photo that many of you may have seen before. It's the famous Douglas Engelbart, mother of all demos. And really the remarkable fact about this photo is that it is taken in 1968. And what you can see here is that Douglas is actually using a mouse, a computer mouse. He's using a graphical interface. He's actually like using the system interactively, which was kind of really cool back in the day, like when most systems were very batch oriented. Also, it was actually done remotely. So the kind of some stuff, like kind of some backend stuff was running at the different locations. So like truly an amazing technical feat in 1968. Of course, like one thing that oftentimes goes unmentioned, and I think deserves like more attention, is that of course it took quite a lot of technical effort to kind of pull together this demo, and they had custom made modems, and they had custom microwave links, and they had custom, of course, software and like all that stuff to actually be able to showcase this view of the future. And I guess the kind of a thing that I want to emphasize here is that like what you see in this photo in 1968, it was technically possible, as obviously witnessed by this demo. But then on the other hand, many of these things seen here like weren't mainstream for the next, didn't become mainstream for the next like 15 to 20 years. I guess it took at least like 15 years for like computer mice even to become really popular. So there has always been this interesting gap between what is technically possible and then what is easy enough and like what is widely available enough so that actually like the vast majority of users can start benefit from these technologies. And I think that this is indeed the kind of the big macro trend of our like industry computing overall. Another kind of a really like thing that like is worth mentioning about this photo is that what really made this demo so cool wasn't the fact that he was using a computer and the computer was doing some number crunching. Of course, like already in 1968, they had computers for like a good number of years, almost 2 decades, I guess. So that wasn't the cool part. The cool part was really the human interaction and the fact that like the human being was actually able to like use this machine. So again, I mean, this was a good example of the usability and productivity really being the kind of the killer feature of computers. Now, I just wanted to start this presentation by kind of giving this really long kind of a like arc of history, like kind of how I've been personally observing this field. Obviously, it wasn't called MLOps back in the day, but like what it was still is that already back in 2000, I was actually at the startup that was trying to commercialize artificial neural networks. And ever since then, I've been building machine learning infrastructure at different companies and in academia and so forth. So these are kind of my personal observations, like what has been causing headache at different points in time. So like I wanted to highlight a few different dimensions here. In each one of these charts, like very unscientifically, you have x-axis on time, like whatever has happened over the past 20 years, and the y-axis is kind of the headache meter, like how much time and energy was spent on these concerns. And now, as you can imagine, like if you could take a time machine, hopefully you can't, but I mean, like if you could go back in time to the year 2000, and you had to build machine learning infrastructure, like really like one of the first concerns is that like you need to find the hardware to run anything on. And of course, this is way before like any cloud computing. So most likely it means that you have to start racking and stacking computers by yourself in your office. And this is actually what we did by ourselves as well. And like we had 2 servers, I think that like they had 2 CPU cores each, like of course like you had to worry about networking, storage, all that stuff. So overall, like good amount of time and energy was spent on that hardware setup and like finding the vendors, designing the right architecture, so forth. Now in contrast, if you think about the situation today, I think like most companies like would just click the button and sign up for an AWS account and then start using cloud, or like of course GCP, Azure, like whoever is your favorite provider. And now, of course, you still have some headaches. And of course, like a cloud is by no means trivial to use. But compared to what it was back in the day, especially like when thinking about doing compute at scale, it's massively, massively easier. So by and large, I think it's safe to say that the hardware headaches have pretty much gone away in ML projects. Then the next one is data. And like in 2000, like we had just a couple of hard disks, I guess like a decent amount of storage there, but it wasn't replicated, it wasn't durable, it wasn't particularly high performance. We took backups on tape, and like you had to manage the tapes by hand and so forth. So now if you compare that to modern cloud-based object stores, again, more or less it's safe to say that that type of basic data storage problem has totally gone away. Now, when it comes to overall data infrastructure, if you think the modern data architecture, if you think about things you can do with dbt, Snowflake, Great Expectations, what have you, I mean, of course, it is light years ahead of like what it was 20 years ago. I mean, like maybe the best thing you could do 20 years ago is that you could call Oracle or Teradata, and they will send you expensive consultants and expensive hardware. So in that sense, I mean, at least like from the ML point of view, like data is starting to be in a very good shape. Then it has always been the case that ML is very compute intensive. So it has always been the case that you need to very much care about the performance of your algorithms, like how you distribute your software and so forth. And actually 2000 was even before MapReduce, even before Hadoop, of course, the best thing people had is some kind of a high performance computing MPI, what people have been doing since the days of supercomputers. But again, I mean, that took a massive amount of effort to handwrite the C and C++ code, even like for networking and all that stuff, so that you can actually train anything at scale. And it was really amplified by the second point, which is about the models. So of course, it was very hard to find any off-the-shelf modeling libraries. So in academia, people created some research prototypes and occasionally shared their C code in tarballs. But compared to what you can get these days in TensorFlow and PyTorch and Keras and so forth, like it almost like it feels like it's safe to say that the kind of these like low-level modeling libraries are like a quote-unquote a solved problem. I know that, of course, like everybody who's now working on these libraries like very much shakes their head thinking that by no means like we have reached any kind of a peak ML modeling libraries. I know that there will be amazing things that will be possible in the future. But again, I mean, if you look at the long arc of things, like for most business applications, especially like these modeling libraries are in a very, very good shape. Now, if you look at the other column on the right-hand side, interestingly enough, it kind of feels that the software architectural problems have increased, in a sense that back in the day, like when we had a couple of C modules and like some algorithms that like compiled to binaries and then they were glued together using shell scripts. In a way, I mean, the complexity was manageable. Of course, also the problem domains were much smaller and the scale of everything was much smaller. But now, especially if I reflect the experience like back in 2000 versus like what is today at Netflix, for instance, like where they have hundreds and hundreds of different ML and data science use cases, the complexity of overall like kind of the software stack has absolutely exploded. And some of that complexity is accidental. It really doesn't have to be there. But on the other hand, like some of it is really justified in the sense that while we are trying to apply ML to more and more real life use cases, and the world is a complex place. So, I mean, with that comes a kind of some amount of inherent complexity. So we just have to learn how to live with that complexity. And I believe that it will be only increasing. I mean, we can't just get rid of that entropy. Another big one is that back in the day, just the fact that you were able to build a model was a feat in itself. So now there wasn't that much concern that, okay, so what kind of issues like we might have in operations? Of course, the kind of the number of customers was really limited as well. So there was absolutely like no talk about model observability or model explainability, and not to mention like ethics of AI or anything of that sorts. And like realistically, the results didn't always matter so much. I mean, these projects were not always so business sensitive. So, I mean, that was fine. But of course, these days, as the results are starting to matter more and as many, like more and more businesses are actually like driving their actual bottom line using these models, I mean, it becomes very important that like you really focus on that aspect. Now, also back in the day, it was actually a source of pride that there were only a handful of people who were actually able to use the system. It was actually seen as a competitive moat that only few people in the world like knew how you can build large-scale neural networks. And of course, I mean, this is another trend that like you can really see shifting quite radically over the past even 5 years. That maybe even 5-10 years ago, definitely before TensorFlow, there was this idea that these topics like are very much like in the realm of academia and research, and like you need to have a PhD to be able to kind of do anything of value in this space. But that has, of course, like totally shifted over the past couple of years. We have way more people. Also, what's super interesting that like people are coming from different science backgrounds. I mean, not only computer science, but oftentimes we work with people who are not computer scientists, who are not software engineers by training, and they need to be able to be productive and like build these applications really well. And now lastly, like by diversity, I mean not only the diversity of people, which I think it's really amazing, but also the diversity of different applications, like where we are trying to apply ML. So again, I mean, as I mentioned at Netflix, it's a really like the wide spectrum of everything between computer vision, natural language processing, classical statistic operations research, like where you can apply these techniques. So of course, like we have a very wide spectrum of different types of applications these days, and like somehow we have to learn like how to deal with the kind of that variety and diversity that comes with that. Now, like the common theme here, again, I mean, like speaking to the topic of this talk, is that like everything on the left-hand side kind of feels like a machine problem, kind of an engineering problem, technical problem. I mean, really not to underplay the importance of these things, but if you think about like hand optimizing your networking library, like for some kind of a distributed training, again, I know that there are people who do it, like, thank you for your efforts, but I mean, for most people, they don't have to care about that anymore. The same thing with the data storage problems. I mean, most people don't have to care about file system implementations. I mean, not to mention anything related to hardware. And the same thing with modeling libraries, that like fewer and fewer people have to kind of write their own modeling libraries. Even back in the day, I remember when I joined, Netflix was using some hand-built modeling libraries, but even those are like going away quite fast. And then on the right-hand side, I mean, it feels that like solving the complexity problem, the kind of observability SLA problems, solving the usability problems, and solving the diversity problems, they are all human problems. I mean, there isn't technical solution to dealing with the real-world complexity, and there are definitely no technical solutions to just like kind of solving that like a human-computer interface like once and for good. I mean, it is of course like one of the core questions that always stays with us. And of course, like especially when it comes to the diversity of applications, someone needs to have the domain knowledge to understand like what is the business problem that we are trying to solve. And again, I mean, it requires quite advanced general AI before we can have the system to understand the business problems and the metrics that matter by itself. And like I think it probably like would be safe to say that it probably won't happen in my lifetime. So I think that like we can safely say that if you consider like everything on the right hand side a people problem, you are probably not too far off. Now going back to that kind of like the first photo like from 1968, and like kind of how all those things were already possible at the time, but I mean nothing was easy enough. I mean it kind of feels a bit of the same situation today with MLOps, that if you think like where we are today, it really definitely feels that like most things are technically possible, but really not many things are easy enough. And I think that again, I mean this is really the key challenge like for all the tooling in this space, that like we kind of have to keep moving that red dot towards the right hand side. Of course, at the same time, like we want to have people to advance like really the fundamentals and things on the left hand side as well. But by and large, it seems that like not only like we haven't reached the current kind of the level of possibility, like trying to kind of like really make everything that's possible today easy enough, but also these like these challenges are only increasing on the right hand side. So in that sense, like not only we have to kind of keep pushing the red dot to the right hand side, but I mean we also have to take into account that the right hand side is kind of like escaping from us all the time, and things are kind of becoming only more and more complex, more and more diverse as we are applying ML to more and more use cases. So I guess another way of looking at this is that if you look at the technical capability, I would argue that like today, the technical capabilities of like what kind of models we are able to build and like what is our theoretical understanding of different problem domains, I mean, it is way above like what kind of things get deployed in production. I guess in other words, I don't think that many projects, maybe self-driving cars is a good example where like the technical capabilities maybe kind of like pretty much like a meeting, like kind of what we would like to do today. But I mean, for most business-oriented data science problems, machine learning problems, technically like kind of like we are able to do all this stuff. But it's just that like due to these usability problems, we are not able to deploy, not able to iterate these things to the point that like they would actually work well enough in production. Now, I guess really the like kind of a call to action like for everybody here, especially who's an MLOps tool builder, is really to focus everything here in the middle. And now, if you happen to be in academia, if you are a grad student, if you are a professor, well, of course, I hope that many people will keep working here at the very top and like keep pushing like what is technically possible. Of course, I mean, that development needs to continue. And then like on the other hand, like if you happen to be a business person and like you have some very concrete application ideas, like where you could potentially apply ML, I mean, of course, I do think that we will see absolutely amazing applications like being built over time. I think that will be rapidly increasing, but there is that space in the middle that we have to fill. And it's I hope that space will be narrowing over time. But I mean, as of today, if we look at the situation today, that gap indeed seems quite wide. And to highlight what I mean that the gap seems wide is that like very concretely, if you think about what the machine learning project looked like, maybe just about 10 years ago, 2010, actually some of these modeling libraries were available. So definitely had SciPy. I think you had scikit-learn back in the day as well. So in a sense, I mean, like quite a number of different problems were solvable already back in the day. And like actually like if you use Python, like kind of some things were actually quite easy as well. So this is the classical like MNIST example using scikit-learns, like just using KNN. I mean, in like 2010 era, nothing special. Now the question is that, okay, how would you deploy this in production? 2010, like probably you would just like run the Python script with cron or something of that sorts, but at least it kind of works. But now if you contrast that to the situation today, this is the MNIST example using SageMaker. I don't have anything like specifically against SageMaker, but it's just like highlights the complexity and that like usability gap that we have today. That that in a sense, you might be using the same libraries under the hood, but I mean, we have introduced these other layers of complexity on top that have, in a sense, like made it even harder to kind of get even basic stuff done. And now, of course, I understand that like we are like capable of doing more amazing things these days, and like you can launch these big instances and you can use these fancy libraries. But I think that there's a good amount of accidental complexity here as well that just doesn't need to be there. And for again, I mean, like for everybody who's operating in this space, I mean, this is really the kind of the call to really focus on that like usability gap, and like consider that given that all these things are technically possible, there's really little reason to make them unnecessarily complicated. I mean, things that are complicated probably need to be so, but I mean, like the basic stuff like this, and like which I think covers most of the business applications, there's really no excuse why it needs to be overly hard. Now, the interesting question is that, okay, so how would we go about solving this question? Like, how would we actually go about fixing that gap, and like what kind of principles we can follow? And I think always like in a situation like this, like when we are kind of trying to like a chart a new territory, or think like what's the kind of a direction we should take. I mean, a good starting point is at least to look into the past. Of course, we shouldn't expect that what people did in 1960s or 1970s or 1980s directly applies to today. But it is actually quite amazing that given that the long arc of computing has always been about making possible things easy, how many lessons that have been actually learned in the past we can leverage nowadays, like with MLOps as well. And here the kind of one example that I really want to highlight is actually that of Unix. And for those who don't know, I mean, Unix is, of course, the operating system that is now mostly seen through kind of Linux. I guess Linux is a variant of Unix. And of course, like many operating systems existed before Unix as well. Famously, there's one called Multics. And although it oftentimes feels that like as things become more advanced, they kind of become more complex as well. Occasionally it happens the other way around as well, that Multics that predates Unix was actually supposedly more complex and more kind of capable than Unix that came after that. But the key feature of Unix that actually made it popular, and like why we are still using Unix on most of the kind of devices that are actually deployed, including all the Android phones and so forth, is that like it was super fun to hack. It was super easy to test different systems. It was actually focusing on that usability aspect and like how to make it easy for developers to try out different things, how to iterate things and quickly and so forth. And this was really indeed already back in the day a big contrast to the kind of many of the existing systems that really were like much harder to use. And I don't think that they had YAML in the day, but many of you who have been like dealing with YAML these days, I mean, can maybe empathize with this idea that, well, I mean, like things can be just like overly like kind of a non-human centric. And now, I mean, to make this even more concrete, I'm now kind of highlighting how we thought about the whole space at Netflix. And at Netflix, when we started thinking about that, okay, so how can we actually build this tooling? How can we close the gap? And now if you imagine the situation at the company like Netflix, they definitely had plenty of existing infrastructure. So again, technically everything was possible. There was a compute layer, there was a data infrastructure, there was an orchestration platform. So definitely the problem wasn't that something was technically impossible, but it was really the question that, okay, how do we close that gap so that people who come from very diverse backgrounds can build very diverse applications and solve real world business problems? And then like when we thought about it, like it is really a journey, like how you go from prototype to production. There are many things on the way, and that's, I think, that the key challenge for something like MLOps, that there isn't a single problem that like you can solve. I mean, solving only distributed model training or solving only model observability or model explainability or experiment tracking isn't enough, but you really have to think about like every single detail on the way, starting with the very basic question that, okay, where do you develop the code in the first place? I mean, you can start with the laptop, but maybe, for instance, having a cloud-based workstation, like if it's easy enough to use, easy enough to spin up, I mean, it's something that can boost productivity. I mean, definitely makes at least many operations faster. Then like we very much wanted to leverage notebooks. Notebooks are really good for like data discovery, for exploration, for quick prototyping. But quite soon, as like many of you know, I mean, you can hit limitations of notebooks and you start thinking that, okay, maybe I need something that is a bit more structured, like a bit more like versatile in the sense that like you can deploy it to production, like you can scale it out and so forth. So hence, like many people structure their ML and data science projects as workflows these days. So you want to kind of have some kind of workflow system. And now, like when you start building workflows, then the next question is that you are not only building a single workflow, but you keep iterating on the workflows. And definitely you want to, of course, like version all the code. I mean, this is what all software engineers, of course, do all the time. But now in data science, you also want to probably version the models, like somehow register the models as well. You want to keep track of all the experiments. And in the best case, you can also like keep track of everything that happens in the pipeline. So kind of thinking about that versioning question is really important. Then the most obvious idea, like when it comes to scalability, is that, okay, so can I just have the biggest possible laptop? Can I have a big box, like with a lot of memory, with a lot of CPU, GPU, so I can do as much as possible locally? Again, I mean, to optimize for the usability. Again, I mean, in the engineering point of view, it would be nice if you can just like chunk your work in tiny, tiny pieces that you can farm out in the cloud. But oftentimes, just in the usability point of view, having like starting with the vertical scalability, starting with the big computer, so you don't have to change anything in your code, you don't have to change the paradigm, is very convenient. Then the next part is, okay, so I mean, like once you have like hit the limits of vertical scalability, at some point you have to start using multiple machines, how you do that effectively. And once you have multiple machines running, you have this problem that, okay, so how do you get data? How do you feed data in your workflow so that you don't take the whole Spark cluster down or whatever it is when you are trying to ingest in each one of those like a data processing or model building steps? So that's something to consider as well. And then finally, as you are getting closer to production, at some point you realize that you are not supposed to run the whole workflow by hand, but I mean, there's supposed to be some kind of a scheduler, maybe some kind of a workflow orchestrator that can take your workflow and then, let's say, run it every time like the data updates, or maybe run it once per night or whatever is the right schedule. And then like what we noticed is that then once we had these pipelines running in production, occasionally they failed. And one common reason why they failed was that something changed in their environment. Maybe the package dependencies changed. And of course, now many of you know that a best practice for production deployments especially is that you have some kind of a frozen environment. Maybe you use a Docker container and like you don't let that change like kind of by accident. But again, I mean, now the question becomes that who's going to build those Docker images, who's going to take care of those dependencies? And again, different companies have different solutions for that. But I mean, again, something that you kind of have to consider. And then like as you are like getting to production, at some point you realize that there isn't a single production. There are many different like types of production, and like especially like you definitely don't want to just like flip the switch and start using some experimental version of the model, but you probably want to A/B test these things. So you kind of have the situation that you have to run multiple parallel workflows at the same time, and like how you deal with that was the question. And then finally, after you have done all this and like everything is happily running in production, there's the question that at one night inevitably something will fail, and you have to be able to understand like why things fail, and then you have to be able to go back to your machine and start debugging, start troubleshooting, and start improving the model. So now I just want to quickly highlight like some principles that we applied to Metaflow specifically, and these are actually the principles are directly taken like from that book, Art of Unix Programming. So by the way, the book is freely available. Highly recommend reading that. It's really educational, like for anybody building tools these days. All those lessons learned, all these principles are quite timeless. And of course, like not surprisingly, the first one here is the rule of simplicity. I mean, don't make things overly complicated if there's no reason. There's enough real world complexity. And if you remember that complexity is only increasing. So let's at least try to keep our tools as simple as possible. So here, like in the case of Metaflow, the idea was that, okay, so assuming that our users are familiar with the Python to the point that they can write Python in notebooks, what's the simplest possible way to, let's say, express that workflow? Like really reducing like every unnecessary line of code, every like kind of a piece of boilerplate that's really like not necessary, and like how you can express workflows like this in Python code easily. And then also like how you can test them, not only like kind of write the configuration, but I mean, test them that do they actually work. So that should be simple enough. Again, I mean, if you want to get details about Metaflow, there are many other presentations that you can watch online. So I won't be going into details. This is more of a kind of a teaser, like how we thought about designing such a system. Another one, which is really a good, again, I mean, like time-tested lesson, is the idea of clarity being better than cleverness. Unfortunately, many systems that have been built, especially for distributed computing, are really clever, and they try to be like quite magical, like when it comes to handling large amounts of data and like handling large amounts of compute. And they are amazing when they work. but often, especially when they fail, it can be quite unclear like why they fail. And oftentimes doing like a very simple but super clear things not only like actually makes it easy for people to build stuff in the first place. Like let's say that, okay, so although it's really stupid idea kind of to just use pandas data frames, but on the other hand, it's really clear. It's really like something that many people can do. But especially when it fails, oftentimes it's quite easy to find help, let's say in Stack Overflow, and like you can kind of self-serve that debugging experience instead of having to reach out to, let's say, to the engineering team. Another big one is this idea of having the small pieces like that are interconnected, and like having a well-defined interfaces between them. So of course, like in a DAG, I mean, this is easy to realize that like you have these different compute steps. But one thing that oftentimes gets overlooked in these workflow orchestration systems is that what is exactly the clean interface between the different steps. And like one of the most important questions there is the data flow. And like practically never these steps work in isolation. They are not independent. They are very much interdependent, and there's some data that's flowing across the steps. And like, for instance, in Metaflow, we decided to have these artifacts, like here in this case, self.x, treated as a first-class citizen. So this data is passed around automatically. So when you do self.x equals 1 in the step start, when you go to A, that self.x is available, and like you can just increment this. And now when you look at the code, I mean, this of course seems totally unsurprising and like kind of like really pedestrian, but the magic here really is that now these steps can even like execute on different compute platforms. It could be that one of these steps is executing on your laptop, the other one could be executing in the cloud, and the data is automatically moved between these different systems. Another big one, I'm sure that like even in this conference, like we have many talks about model observability and like how important it is to make everything visible and debuggable in your machine learning workflows. It is indeed an important feature. And like what we decided to do is that we wanted to leverage notebooks to make this possible. So now those artifacts that we just discussed, you can open a notebook and you can just see that like what is the value, what was the value of any one of these artifacts in your past execution. So now even when something failed, you can kind of go back in time and like try to inspect the internal state of the workflow to understand like why it possibly failed. So definitely convenient. This is like one of my favorites, the idea that programmer time, data scientist time is expensive, and it's always preferable to use machine time instead of like human time. And now this is actually something that's way easier to do these days than it was maybe even like 10, 15 years ago, thanks to the cloud. So instead of like spending a lot of time, let's say, optimizing your pandas data frame operation that everybody knows that is probably quite inefficient, you can just get the big box and like, well, maybe you take a box with 228 gigabytes of RAM, and like, of course, pandas is very inefficient, but I mean, who cares? Like if you can just like kind of run this function, and like the important thing is that you are not taking that machine for like 24/7, but you're only running it maybe for like 20 seconds as long as this operation executes. And now instead of like the human spending time on optimizing this piece of code here, you can just like kind of spend a few more cents in the cloud, and usually that's a pretty good deal. Another one is really to treat failures as a first-class citizen. Oftentimes, many systems are quite optimistic, thinking that like hopefully things won't fail, and like the failure is kind of an exceptional case. It's actually unfortunate that the exceptions are called exceptions, because like oftentimes failures are pretty much the norm, not an exception. So that's why like treating these like a failure scenarios and letting the user actually like to understand like, and then like kind of a control like what happens in different scenarios can be quite useful. Again, that goes back to the point of clarity as well, that it would be of course nice if we could handle all kind of failure scenarios automatically, but sometimes it's just more clear to make it obvious that like, okay, how the system is going to behave under an error condition, instead of like trying to be very smart and then like kind of a double fail when even the failure handling fails. And now this is of course like really like a famous thing and like common thing in like all the MLOps talks, that okay, so how do you interact between prototype and production? And I think that this is of course like very relevant for any software projects, like when it's well known that like you shouldn't engage in premature optimization. But I think that this is like 10 times more important for machine learning projects that are all about empirical kind of experimentation and quick iterations and so forth. So that's why, for instance, the system that we have, Metaflow, you can a prototype locally. You can use like you can execute everything on your laptop. You don't have to set up any infrastructure. Like you can quickly kind of test things as you would do in a notebook. And then like the deployment to production, again, knowing that there are many different shades of production, happens like through a single command. So nothing more complicated than that. And like, given that like all these executions are namespace, they are like kind of, they get their own isolated environments. I mean, it's totally fine that like you can even have your own kind of a copy of what you kind of have own your personal kind of a staging area in production where you can actually see how your experimental code would work in production. And then like you can have this like a gradual process of like maybe promoting it kind of to kind of take care of a larger share of traffic and so forth. And then, like, as I mentioned, like then the debugging needs to be treated as a first-class citizen as well. So kind of you want to be able to resume things that fail in production and then kind of go back to the drawing board. And like based on the failures you are observing and based on the inefficiencies, inaccuracies of the model, you kind of want to keep iterating and like kind of testing better and better versions, go back and deploy another version and like kind of keep kind of moving through these cycles as many times a day as possible. And of course, that is indeed the kind of really the key of all high-quality MLOps systems. Now, already back in the day, like they knew that, well, I mean, the future is going to happen sooner than you think. This is especially really obvious to environments where you have many different machine learning applications. Like I mentioned at Netflix, we had anything between computer vision and natural language processing and operations research and whatnot. So it would have been a mistake to overfit a system of this sort to a particular kind of use case because we knew that people have infinite appetite to try out new things. So we better like design the system in such a way that there's a lot of flexibility to try out all kinds of crazy ideas and like experiment with like new kinds of models and new kinds of data sets and all that stuff. And that like idea is really captured by this diagram, which shows that, okay, we have this full stack of different pieces of like systems that we need to be able to execute these ML projects, like all the way starting from the, how do we get data, how do we run compute, how do we orchestrate the workflows, how do we version these things, all these things that we discussed on the timeline to the production. And like all the way at the top, we have these questions that, okay, what kind of modeling libraries we use, how do we do feature engineering? And now the key to extensibility and like the key way to address the diversity problem is that like we leave a lot of flexibility and freedom at the top of the stack for the data scientists to choose the best modeling approach for each problem. And like even for things like feature engineering, I mean, if you think about the feature stores, for instance, it is one thing to have a feature store for computer vision, and it's quite another thing to have a feature store for natural language processing or maybe some more like relational data sets and stuff like that. So it's very hard to have one size fits all, which is why, I mean, distrusting all claims for one true way is actually still good advice. But then on the other hand, like at the lower layers of the stack, you can afford being more opinionated. So for instance, like you can have really nice paved paths for accessing data, doing compute and so forth. And like you can handle that diversity at the top of the stack. And now maybe as the last point I want to highlight, and this is of course like one of the most important points, is that like building all these systems from scratch like wouldn't make any sense. There's this like a very good advice that says that like you should be separating policy from mechanism and interfaces from engines. And the way, let's say, how Metaflow treats this like a full stack of ML is that instead of trying to reinvent any of these layers, again, I mean, technically everything is possible, so there's really no need to do that. We can interface with the existing stuff like the compute layer, like existing data warehousing solutions, like different workflow orchestrators. And of course, like for model operations, we have excellent tools. And then finally at the top of the stack with different modeling libraries. So we can leverage like all those tools that make these things technically possible. But then we want to wrap everything in a common policy, in a coherent interface, exactly to address that usability gap between like kind of what people are able to deploy today and like kind of what is actually made possible by these amazing pieces of infrastructure. So now in the end, I just wanted to kind of, again, I had this like a shameless plug like for the book that I've been writing. So if you are interested in this domain, I mean, definitely take a look at the book. I'm really interested in hearing your feedback. I mean, it is still in early access, so I'm still able to kind of change things. So I definitely would like to hear from you. I mean, if you have like a strong feelings, especially if you think that something absolutely doesn't make sense, so we can still fix it before it goes on paper. So I guess that's pretty much it for today. We have a Slack community if like these topics pique your interest. I know that like many of you are of course like here at this conference because you happen to be interested in the domain. So we have many people talking about MLOps and related matters at the Slack. So feel free to join. And also if you have any questions, I'm really happy to answer by email or like kind of on Slack or wherever you find me. Thanks a lot.
Yep. Thank you, Ville, for the insightful talk. Just want to give a heads up that the other sessions are starting, but if you guys do have any questions, please write in the chat, and if we could spend a couple time to answer those. First off, I just want to say I really like the kind of the way you framed it, that everything is technically possible, but nothing is easy enough in practice, and that is definitely where we're at currently. I guess a very high level question is, you introduced a lot in the sense the prototype to production, the I guess the full life cycle. Where do you see the most, I guess, which part of it do you see companies struggle with the most in terms of bridging that gap between the, yep.
Yeah, good question. I think there are gaps everywhere, and like depending on the company, it might be at like in the very early phases. It's kind of actually like even amazing. I think like how ill-defined is this like a concept that, okay, so where like should we even prototype these systems? I mean, like many companies use notebooks now. I mean, you probably don't want to run notebooks on your laptop. So where do you run the notebooks? That's why we have all these companies like building different notebooks platforms. Again, I mean, like, well, maybe you should have some kind of a cloud workstations, but setting them up is non-trivial. So at the very beginning, like we have already some problems. And then all the way, of course, scalability is still like harder than it should be, even though, I mean, the cloud kind of really technically makes it possible. But I mean, that's just those paper cuts on the way. And then, of course, orchestration, still a big question mark. Like many companies have, let's say, different Airflow instances for different departments instead of having a one scheduler that like could help to orchestrate everything together. And then, like as it's well known, I mean, at the very end, how do you run A/B experiments? How do you like monitor your models? It's still an unsolved problem. So I think that there are like kind of many gaps on that way. So I don't know what's the worst part. I guess it really depends on the company. I mean, some companies have solved some parts of the journey really well, others some other parts. So it really depends.
Definitely. And would you say, is there a correlation between the maturity of the company and certain areas that it's a little lacking in, or is it just kind of uniform across, very case dependent?
Yeah, I think that like the two things that like come into play there is that, well, I mean, first, like, have you figured out the way to actually make money with ML models, and like how critical it is for your business? So for instance, before Netflix, I used to work at an ad tech, at the marketing technology company where there was a very large scale machine learning system, like running targeted advertising, and like that actually had a direct impact on the company's bottom line. So you had even CFO like looking at the model performance. So obviously like there was quite some investment in the model observability and so forth. So that makes sense, and that's why I mean some companies are really able to focus on that. And usually it happens like for a very specific use case that these companies worry about. And then the other one is actually like more on the people side, more organizational, like kind of how enlightened the management, the leadership is about like this experimentation culture that like, well, I mean, we need to have a platform like this. Of course, the big question is that, okay, why do you really need to care about this stuff in the first place? And like, if you think that machine learning is like any software engineering project that you build it once and then you deploy and maybe occasionally you update it, well, maybe you don't see a point. But then like, if you realize that like the experimentation is really the first class citizen, data is like very much the first class citizen in these systems, then of course, I mean, you start investing more in these platforms, and then like kind of maybe you start like filling in the kind of the worst gaps that you have in your environment. But yeah, I mean, there's definitely a lot of variations.
Mm-hmm. And in a sense, they kind of feed into each other in the sense that if you have a model that actually drives the bottom line, then management will actually care more.
That's right.
Yeah,
absolutely.
Definitely. As our field matures, we really need, I guess, the business leaders to also kind of understand that it's different from traditional, I guess, software deployment. There's a complete different cycle.
That's right. But I think that's why inevitably it will take still like a few years like before we get there, because these changes are always slow. And I'm sure that like if 1968 they would have said that it takes like 20 years before like everybody uses a computer mouse, maybe back in the day, I mean, nobody would have been surprised, but 20 years feels like a long time. I hope that it doesn't take so long for our fields.
Yeah. And I guess talking about the computer mouse, I want to kind of pick your brain about, the computer mouse really abstracted away or made it more accessible for or usable for users to kind of interact in or interface with computers. What is your vision of MLOps in this? Do you see something down the pipeline or something that would have that type of impact?
Yeah. Well, I mean, first, I do think that ML will really eat the world in a sense that we will try to apply ML and we will be successful in applying ML to all kinds of use cases. So we apply it to to business processes, to different products, even physical devices. So, I mean, I think definitely a defining feature is that there won't be a single way of doing ML. It's the same thing as if you had asked, maybe in 1960s that, okay, so what is the one way of developing software? Well, I mean, it's one way to do one thing to build the embedded software, another thing to build web applications and so forth. So, and I think that the same thing applies to ML. So I know many people have been thinking that, let's say, is something like auto ML going to take over the world? And I think that the answer is that maybe for some domains, and then is deep learning going to be applied everywhere? Well, yes, sure, for some domains, maybe not everywhere. And now I think that one interesting parallel is to think about e-commerce and what it meant to build and let's say a web shop, e-commerce store, in I don't know, a 1990s or a 2005 or something. And you had to think about the full stack, from the beginning, by yourself, load balancers, how do you structure the application, what kind of databases, all that stuff. And today, in contrast, you can go to Shopify or you can go to Squarespace and you click, you don't write a line of code. And anybody having a mom and pop shop can do it. And I mean, for some application areas, I'm pretty sure that will happen for ML as well. Again, I mean, not for everything, but I think that is, of course, the vision, for some things, that it just becomes such a usual part of our society and how we develop software that it becomes a non-issue in some areas. And then there will be companies who see it so strategic that they will be really even pushing the boundaries what is actually possible.
Mm-hmm, mm-hmm, definitely. And I really like the idea of with the e-commerce parallel, where when I guess it started out, there were a lot of considerations. That's kind of close to where we are at, where I guess for the early days of ML, it was basically finding low-hanging fruits and trying to solve those problems. But as I guess the application increases, it's trying to solve a way bigger problem, like self-driving itself is such a complex problem, right? And I think the future of ML also will be addressing even more complex problems, right?
That's right.
And as we move into the complexity, we also want to be able to allow that usability where it's now just open an account, add some info, and now you have an e-commerce store on top of that.
Yeah, and I think honestly, I think almost by definition, the complex problems, because we keep what's complex today won't be complex tomorrow. Something else will be complex tomorrow. So I think that some things will always be hard, but I think at least the simple things should be easy. And I think that's the problem today, that even it feels that even the simplest things are not easy enough. So let's say you're a business and you want to build a model to estimate the customer lifetime value or churn, and you have a super simple regression, and you just want to have a really nice environment to not only to iterate on the model, but also make sure that those results can be integrated to different business systems downstream and so forth. And you can monitor a result and all that stuff. So, and even it feels that we are not yet at that stage, that we can't make logistic regression easy enough. So I think that there's work to be done even on the simple side. So
definitely. Well, thank you so much for joining us today. Really appreciate you taking your time. And thank you everyone in the chat. I hope everyone has a great day today.